Hello again, geometry students. Here we are with the second set of notes. So today's notes is about clearly segments, congruence, midpoint, distance formulas. I'm sure distance formula is in here. We'll see. We're not going to talk about these three things. So this is a number line. Y'all have seen it used a million times before. Just counts all the numbers. Every number has one spot. You could imagine like a half would be in here and -4.5 would be in there. But this is like called a coordinate. These definitions you don't need to really know. It's just that's just in here. But if I want to talk about the distance from between 2 points on here, I'd say like here's A and there's D. That distance from -7 to 5 looks like that distance is 12. And the length of DA, so you can imagine the segment DA, which stretches from A to D. The length of that segment is the distance from A to D. This is very obvious, but the notation is not. So we denote the length of DA, of segment DA. We say that that's DA. You notice there's like no hat on this. It's not like with the 2-arrowed hat or the 1-arrowed hat for array or the no arrowed hat. It's just nothing. So no hat implies distance. Okay, if there's no hat on it, I assume it's a distance. The difference between this and this is that the distance from D to A, this is a number. In this case, it's 12, but it could be any number. And this actually represents a segment. Like this represents like the physical thing that goes from A to D, and this represents a number. Like you might say, I'm 5 feet 11 inches tall, but you never say I am 5 feet 11 inches. Like there's a difference between the thing that you're measuring and the number that you get when you measure it. And that difference is indicated by putting a hat on DA for the segment and not putting a hat on it for the distance. So that's kind of important. How I mark, I'll put a star next to it. That's important. Don't forget that this is the number and this is the segment. I don't know, finding the length is just, I mean, you could count. You could count, that's one way to do it. You could subtract the coordinates. You could say like the coordinate of D is 5 and the coordinate of A is -7. You subtract them, 5 minus -7 is 12. That's how you find it. Length cannot be a negative number. Basically, the distance from D to A is the absolute value of this, the absolute value of the difference in coordinates. If we talk about, if you want to, we can talk about absolute value later, but we're talking about the lengths of segments. You just figure out distance, it can't be negative. So if you get -12 here, like if you had happened to have been silly and done -7 minus 5 and gotten -12, you know it's really the absolute value. And that's always going to be positive. That looks like a parentheses. I'm going to fix that. Like that. So this is nothing really earth-shattering here. The distance, you guys know how to find distance on number lines. We're just kind of formalizing it. This is our first postulate. Postulate is like a statement about math that we just assume has to be true. You don't prove postulates, you use them to prove other things. So the assumption here is the segment addition postulate says that I have like 2 segments on the same line like this. Like if A, B, and C are all on the same line, then the length of AC, notice I didn't put a hat on it because it's not a segment, I'm talking about AC itself, is the length of AB plus the length of BC. And this ought to make sense if AB is this one and BC is this one. Like the length of the whole thing has to be the length of this one plus the length of that one. Like that's just, it kind of makes sense, but In geometry, we're going to say a lot of things that seem like they're obvious, but that's how geometry works. We like want to make sure we're right, so we make sure we say every obvious thing. We're not skipping any steps. Segment addition postulate, and we use it to solve problems, and we use it to solve algebra problems because, to be honest, a lot of geometry is about algebra. So it says find the length of KL. That's this little fella here, right? Trying to find that. Well, if the whole thing is 26, then I can write this down. Then if the from I to L is 26, then if I add up all three of these, I should get 26. So the first one is 9. The second one is 11. The third one I don't know yet, but I'm just going to call it KL because that's what it is. And that should equal this whole distance here, which is 26. Now I do a little algebra, maybe 20 plus KL equals 26. And then I would subtract 20 from both sides. Now we get KL equals 6. That's how you do that one. This is basically the same kind of problem, except you have to draw your own picture, but that's okay. So find AC, so I'm going to say this A, B, C. This should probably say something like A, B, and C are all on the same line, but you can kind of assume that they are. It says AB is 16 and BC is 12. So this one, this is just the segment addition postulate exactly as it was stated. The whole length is AB plus BC, which is 16 plus 12, which is 28. And this last one is similar. Again, it ought to tell you that A, B, and C are all on the same line. I'm going to tell you that they are, otherwise this problem can't be solved. So you just write, it doesn't really matter where B is as long as it's in the middle. So it tells me the whole thing, A to C, is 3x plus 3. BC is 11, and this one is -1 plus 2x. So use a segment addition postulate and just add these two. Whatever it is from here to here plus from here to here must equal the whole thing. So from A to B, I would say -1 plus 2x. B to C is 11. That's got to equal 3x plus 3. Now we do algebra, which in theory you guys learned last year. First I'll combine like terms on each side. I'm going to subtract 2x from both sides. So 10 equals x plus 3. 3x minus 2x is just 1x. Then I'll subtract 3 from both sides. I'm going to get x equals 7. So it says find x. So this is my answer. Yay. Wasn't so bad. So that's how, that's unfortunate. That's how the segment addition postulate works. Oh my God, is this thing not going to go away? It's going to be super annoying if it doesn't. See if I can fix that. I did. Magical. All right, back we go. So our next page, more examples really. So maybe this one's a little harder, I think. So we got this whole thing B to E, and it's divided up into 3 pieces: B to C, C to D, and D to E. And it tells me that this little piece is 2, but then the other distances it gives me are like overlapping. So really what I want to say is that the whole distance is the sum of this one, and this one. And then I could hopefully find x or something. But it's not, like, since they overlap, I can't do that. So here's what I think maybe is a good idea. Let's add this 2x, let's add 2x minus 4 and 2x minus 3. Nope, that's a plus. So basically what I've added is this part and this part. But what happens when I do that is I count this middle part twice, because I count it right here in the 2x minus 4. I count it right there in the 2x minus 3. I don't want to count it twice. I just want to count it once. So the way to do that is just to subtract one of them. I know that there's 2 of these little pieces in here. I'm just going to subtract it once. Now I've got this one plus this one minus that thing I counted twice. And that's got to be equal to the whole distance, which is 3x minus 1. So that this side is 2x plus 2x is 4x. Minus 4, minus 3, minus 2, minus 9. 4x minus 9 equals 3x minus 1. Subtract 3x from both sides, get x minus 9 is negative 1. Add 9 to both sides, and I get x equals 8. And it's tempting to stop here, but excuse me, if we go back and look at the question, it says, it doesn't say to find x. It says to find BD. BD is the distance from here to here. And that's the same as this one. Same as 2x minus 4. So BD is 2x minus 4. And if x is 8, then it's 2 times 8 minus 4, which is 12. I'll skip this one for now. We might come back to it later. It's kind of a challenging one. And I'm going to stop this video here and finish up the notes in the next one. I just want to split it up, and it's kind of a good place to stop. So keep an eye out. This is just part 1. Part 2 is coming up.